Elements, compounds, and mixture. Elements. In the early ages, only nine elements: carbon, gold, silver, tin, mercury, lead, copper, iron, and sulfur were known. At that time, it was considered that elements were the substances that could not be broken down into a simpler units by ordinary chemical process. Until the end of 19th century, 63 elements had been discovered. Now 118 elements have been discovered, out of which 92 are naturally occurring elements. Modern definition of element is that it is a substance made up of same type of atoms having same atomic number and cannot be decomposed into simple substance by ordinary chemical means. It means that each element is made up of unique type of atoms that have very specific properties. Elements occur in nature in free or combined form. All the naturally occurring elements found in the world have different percentage in the earth crust, oceans, and atmosphere. Table 1.1 show natural occurrence in the percentage by weight of some major elements around us. It shows concentration of these major elements found in the three main system environment. Natural occurrence by weight percentage of some major elements: crust of Earth, oxygen 47%, silicon 28%, aluminum 7.8%, oxygen 86%, hydrogen 11%, chlorine 1.8%, atmosphere, nitrogen 78%, oxygen 21%, argon 0.9%. Elements may be solid, liquid, or gas. Majority of elements exist as solid, for example, sodium, copper, zinc, gold, etc. There are very few elements which occur in a liquid state, for example, mercury and bromine. A few elements exist as a gas, for example, nitrogen, oxygen, chlorine, and hydrogen. On the basis of other properties, elements are divided into metals, non-metals, and metalloids. About 80% of the elements are metals. The elements are represented by symbols which are abbreviation for the name of elements. A symbol is taken from the name of the element in English, Latin, Greek, or German. If it is one letter, it will be capital as H for hydrogen, N for nitrogen, and C for carbon, etc. In case of two letter symbol, only first letter is capital. For example, Ca for calcium, Na for sodium, and Cl for chlorine. The unique property of an element is valency. It is combined capacity of an element with other elements. It depends upon the number of electrons in the outermost shell. In simple covalent compound, valency is the number of hydrogen atoms which combine with one atom of that element, or the number of bonds formed by one atom of the other element. For example, the following compounds. The valency of chlorine, oxygen, nitrogen, and carbon is 1, 2, 3, and 4 respectively. In the simple ionic compound, valency is the number of electrons gained or lost by an atom of an element to complete its octet. Elements have less than 4 electrons in their valence shall prefer to those the electrons to complete their octet, for the respectively they lose these electrons to have a valency of 1, 2, and 3 respectively. On the other hand, elements have 5 or more than 5 electrons in their valence shall gain electrons to complete the octet. For example, NO and Cl have 5 and 6 and 7 electrons in their valence shell respectively. They gain 3, 2, and 1 electrons respectively to complete their octet. Hence, they show valency of 3, 2, and 1 respectively. A radial is a group of atoms that have some charges. Valencies of some common elements and radical are shown in table 1.2. Some elements and radicals with their symbols and common valencies. Element radical: sodium Na1, hydrogen H1, etc. Some elements show more than one valency. For example, they have variable valency. For example, in ferrous sulfate FeSO4, the valency of iron is 2. In the ferric sulfate Fe2SO4 3, the valency of iron is 3. Generally, the Latin or Greek name for the element is ferrum is modified to end its os for the lower valency. For example, ferrous end to an end in IC for the higher valency ferric compound. Compound is a substance made up of two or more elements chemically combined together in a fixed ratio by mass. As a result of this combination, elements lose their own properties and produce a new substance compound that have entirely different properties. Compound cannot be broken down into its constituent elements by cons- constituent elements simply by simple physical method. For example, carbon dioxide is formed when elements of carbon and oxygen combine chemically in a fixed ratio of 12:3 and 3:8 by mass. Simply, water is compound formed by a chemical combination between hydrogen and oxygen in a fixed ratio of 1:8 by mass.